Hello dear students. From this video onwards, we will be learning what is circular queue and how to implement it using array. Now actually circular queue is same as linear queue. I mean data structure wise, we are going to have array A of fixed size and we will have two counters front and rear just as we had it in linear queue. So declaration of circular queue and linear queue is going to be same. But the behavior of inserting an element or deleting an element will be bit different. Now to tell you what is the difference, you watch this linear queue. The diagram that you are finding is of linear queue of size 5. So only 0 to 4 elements are possible because size is 5. And just imagine the elements standing right now are 30, 40, 50. So front is 2 and rear is 4. I hope you understand this is the frontmost. This is the rearmost. Don't get surprised what happened to these elements. Okay, these elements may be there earlier, but we have deleted them. And you know every deletion is going to increase the front and front has reached 2. So this is the condition of the queue right now. And we have already discussed this in the earlier video that now if you try to insert one new value in this, 60 let's say. So 60 should stand after 50. But as this is linear queue, this is so rigid, this will announce overflow. It will say that rear has already attained the place size -1. Recall the overflow condition that we saw in the linear queue program. So it says 60 cannot be stored, but actually these two places which I am marking 0 and 1 are empty, So it should not have declared an overflow, but that's how the linear queues are made. They say that every insertion will only increase rear by 1. That's it. Linearly, rear will increase. And every deletion will increase front by 1 linearly. So, although the elements are vacant, we get overflow error. Now, what if we go for a circular queue? Just watch. The diagram that I have shown here is a circular queue. Again, I have the same situation where front is 30, that is second element, and rear is 50, that is fourth element. So we have the counters front equal to 2 and rear equal to 4. This is the array. And now just imagine we want to insert 60 in a circular queue. Okay. Then what circular queue program will do is it will see that there is no room after 4. There is no element over here. But then if you go circularly and check this place here, 0th place, is it vacant? Yes, it is vacant because front is standing at 2. The queue is starting from here. So this location is empty and 60 will be dumped here. Now watch, the front counter will remain 2, but the rear counter, which was 4, will now become 0. Watch it. This is still the frontmost, 30. Next comes 40. Next comes 50. And after 50, 60 got inserted. So rear over here is 0. And what if we want to insert 70 also? One more insertion we want to do. Come on, 70 will go after 60 because 60 is the rearmost. So 70 will go at first place. So rear, which was 0, will now become 1. Now the queue is really full, isn't it? And if you are asked what are the elements of this queue, what are the elements of this queue? You should not answer it is 60, 70, 30, 40, 50. I repeat, the answer should not be 60, 70, 30, 40, 50, thinking that this is at the front. So 60 is the frontmost. What you should check is what is the value of the front. Front is 2. So 30 is the frontmost. Then you will go ahead 40, 50 and then go circularly to get 60 and 70. And 70 is the rearmost. Watch the value of the rear. Rear is 1. So that's circular queue, isn't it? That's circular queue. You tell me again, what did you follow? Here we go. Suppose I give you a circular queue like this. These are the indexes. Okay. And if I say that the values are 55, 20, 80, 90. So if I ask you, tell me Tell me in correct sequence, what are the values stored in the circular queue? You would say, I can't say because you give me the front and rear counter. Now I give you front and rear. Front is 3, rear is 1. Okay, so you will say 55 is the frontmost, third element. Then comes 20, fourth element. Then it is 80. And then finally 90. 90 is first element and 1 is rear, last element. So this 90 is the last element. That's how the circular queues can be seen when implemented using array. So when we come back in the next video, we will see how to implement this circular queue. I promise most of the things will be same as seen in the linear queue, like declarations or the function calls will be same, except for the behavior of insert will be bit different and delete also will be bit different, because you have to wrap up from the last element to the first element. You have to go circularly in the array. So that would be the only change. See you in the next video. Thank you very much.